This calls for modifying both the virtual memory part as well as the UBC part of the original system to handle the needs of the global memory system. In particular, what you notice is that the VM and the unified buffer cache, when it wanted a missing page, it used to go to the disk. But here, what we're going to do is we're going to make it go to the GMS, because GMS knows whether a particular page that is missing in the address space of a process is present in some remote GMS. And similarly, if a page is missing from the file cache, it knows whether that page is perhaps in the remote GMS. So that's why what we do is we modify the virtual memory manager and the unified buffer cache manager to get their calls for getting and putting pages. Get page is when there is a page fault, I need to get that page. I would go to the disk normally, but now I go to GMS. Let GMS worry about getting it for me. Similarly, if a page is missing in the unified buffer cache, I go to the GMS to say, get me that page for me. And he will then do the work of finding out whether it is in remote GMS, or if it is not anywhere in the cluster, as we've seen in some of the cases, it could be on the disk. It'll get it from the disk. Notice also, writes to disk is unchanged. Originally, whenever the VM manager decides to write to the disk, it's because a page is dirty. It writes to the disk. That part we don't want to mess with because we are not affecting the reliability of the system in any way. Writes remain unchanged. Only when you have a page fault, you have to get the page from the disk. You don't go to the disk anymore, but you come to GMS, and GMS then is integrated into this system so that it figures out where to get that missing page from. Remember that the most important thing that we have to do in implementing this global LRU, or approximation to global LRU, is collecting age information. That's pretty tricky. In the case of file cache, it's pretty straightforward because it is explicit from the process. When it is making read and write calls, we can insert code as part of integrating GMS into this unified buffer cache to see what pages are being accessed based on the reads and writes that are happening to the unified buffer cache. Because these calls are explicit from the application going into the operating system, and therefore we can intercept those calls as part of integrating GMS to collect age information for the pages that are housed in the unified buffer cache. VM, on the other hand, is very, very complicated because memory access that a process does is happening in hardware on the CPU. The operating system does not see the individual memory access that a user program is making. So how does GMS collect age information for the anonymous? That's why these pages are called anonymous pages. In this case, the pages are not anonymous because we know exactly what pages are being reached in by a particular read or write by a file system. But the reads and writes that a user process is making to its virtual address space are to pages that are anonymous so far as the operating system is concerned. So how does the operating system collect the age information? In order to do that, the authors of GMS, what they did was to have a daemon part of the memory manager in the OSF implementation. That daemon's job is to dump information from the TLB. If you recall, TLB, the translation look-aside buffer, contains the recent translations that has been done on a particular node. So the TLB contains information about the recently accessed pages on a particular processor. Periodically, say every minute, it dumps the contents of the TLB into a data structure that the GMS maintains so that it can use that information in deriving the age information for all the anonymous pages that are being handled by the VM. So that is how GMS collects the age information at every node. So this is where I meant the technical details are very important, because this idea of how to gather age information is something that might be useful if you're implementing a completely different facility. And similarly, when it comes to the pageout daemon, the pageout daemon, normally what it would do is when it is throwing out pages, if they are dirty pages, it'll write it out to the disk. And if it is clean pages, it can simply discard it. But now, when it has a clean page, it wants to discard a clean page, the page out daemon will give it to GMS, because GMS will say, well, don't throw it out. I will put it into cluster memory so that it is available later on for retrieval rather than going to the disk. So this is how GMS is integrated into this whole picture, interacting with the unified buffer cache, interacting with the VM manager, interacting with the pageout daemon, and the free list maintenance as well, in terms of allocating and freeing frames on every node.